All right, today we're going to take a look at 4.3, which is all about proving and applying the side angle side and side congruence criteria. Basically, there's 5 ways you can show that triangles are congruent. This lesson is just focusing on 2 of them, SAS and SSS. So side angle side and side. If you can show that 2 triangles have the same corresponding side angle sides that are congruent or side sides that are congruent, that is enough to prove that those 2 triangles are congruent, that they're the same, okay? So that's kind of the big focus with this lesson. So example 1, explore the side angle side congruence criterion. The key with side angle side is, you can look at these examples right here. It can't just be any sides, any angles, right? With this criterion, I guess they're calling it, right? With this congruence property, side angle side, it has to be 2 of the 3 sides. It doesn't matter what 2 of the 3 sides, but the angle does matter. Notice that I have the 2 sides here, but then the angle is the angle that joins those 2 sides. So for example, I couldn't have a triangle like this and say that this is one of the sides, this is the second side, and this is the angle. That is not side angle side. With side angle side, you have to have 2 sides. It doesn't matter which 2 sides, but if these are my 2 sides, this has to be my angle. It has to be the angle that joins the 2 sides together. So side angle side, like that. So given 2 triangles with 2 pairs of sides congruent and the included angles congruent, verified that the triangles are congruent. That's important. They have to be the included angles. That's the word that they use here, basically saying that the angle that joins those 2 sides, that's called the included angle. So what they're doing here is they're using some rigid motions to see if I can go from this triangle, apply some rigid motions, maybe rotate it, maybe reflect it, maybe translate it to get to this triangle right here. And that's exactly what they're doing. If you kind of follow the steps here, what they're saying is translate, which is just a fancy word of moving that. Looks like it's right and down, right? So they took that original triangle there, they moved it right, they moved it down. So that way those 2 points kind of lied on top of each other. Once they had point Y on top of, they're calling it S prime. I think they're just saying that that's because that's the image. So once point S is on top of point Y, then you'll have this situation right here. Again, nothing changed. We didn't change the size of these triangles. We didn't change the angles within the triangles. That was key. We talked about that in past lessons, that if you want to have congruent triangles, you have to do rigid motions, things that make them stay the same size and the same angles within the triangle. So translations, that's a rigid motion. Just moving that right and down will keep that triangle the same size. Once they did that, what they did was they took this, what is that, TRS triangle, this one right here, and they rotated it. So they took that triangle and they spun it kind of clockwise, right? They spun it that direction. I guess you could spin it counterclockwise too. It doesn't matter which way you spin it, but you rotate this triangle and they spun that around, and then they got this shape right here. Basically, there's that original triangle, X, Y, Z, and then they took that bottom triangle and they spun it. So that way these 2 sides, X, what is that? X, Y, that side right there, would line up with this side right here, RS. So when they spun that bottom triangle up, it kind of formed this shape right here. And you can kind of see they're showing that with little tick marks and dashed lines. Again, a rotation is a rigid transformation. It doesn't change the size of the triangle. It doesn't change the angles within the triangle. That's legal. We can do that. And then the last thing they want to do is reflect it, which again is another rigid transformation. That's legal. It's going to be the same triangle. So once they reflect that left side across that line right here, they're going to have the same exact triangle. You'll notice that they lay on top of each other exactly. So that's just kind of one way that you can, you know what I mean, think about how these 2 triangles are congruent. You can apply these rigid transformations You can shift this triangle right and down. That way point Y is on top of point S. Then I can take that bottom triangle and rotate it. That way they're kind of back to back like that. And then if I reflect it across that side, this left half is going to mirror and lay right on top of that right half. So those two triangles are congruent. They are equal. We get into a couple theorems here. Again, remember theorems are just like properties. It's just kind of a fancy word for saying things that are true in math. So theorem 4.3 is all about the side angle side congruence criterion. Basically, what's going to make side angle side happen. So here's the technical definitions. If two sides and the included angle, that's super key. You've got to have any two sides, but in order for SAS to work, it's got to be the included angle between those two sides. Of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. So if I show these two triangles, if I show that XY is the same length as RS, and that YZ is the same length as ST, and that the two angles, angle Y and angle S, that join those two sides are congruent, well, that's enough information to say that triangle RST is congruent to triangle XYZ. So that's one of the 5 properties, I think we're going to see all 5, that we'll see that prove that two triangles are congruent. Theorem 4.4 is kind of like the end-all statement that you make at the end. After you prove that that side angle side exists, that these two triangles share side angle side, they call it CPCTC. So it's kind of an acronym that stands for a really long word or a really long title. Corresponding parts of congruent triangles are congruent. So corresponding parts, that's like when you say RS is the same thing as XY, angle S is the same thing as angle Y. What is that? YZ is the same thing as ST. They're all congruent. They're all equal measurements, equal lengths. That's corresponding parts of congruent triangles. So because side angle side is true in this situation, we know that these two triangles are congruent. Congruent triangles are congruent. So what this theorem is saying, CPCTC, is that once you prove using side angle side, or in this lesson, side is also going to be looked at. Once you prove that side angle side exists and that these two triangles are congruent, that means that all parts of those two triangles are congruent. So what I mean by that is I can also make a statement, now that I know side angle side exists, and now that I know that these two triangles are congruent, I could also say that RT is equal, or it's congruent to XZ. I could also say that angle T is congruent to angle Z, right? So not only just the parts that are given are congruent or equal, now that I've proved that, CPCTC is in effect, so all parts are congruent to all parts of each of these triangles. Example 2. Apply the SAS congruence criterion. So Ali cuts two triangles from a rectangular piece of metal. So I'm assuming they're saying rectangular because they want those properties of a rectangle to exist here. Remember, properties of a rectangle state that opposite sides are congruent. So the left and the right side, the top and the bottom. Another property of rectangles is that all 4 angles are 90 degrees. So those types of things, that's why they're saying it's a rectangular piece of metal. So keep that in mind. Along the dashed line, so it looks like they're cutting it along that diagonal line right there to make earrings. How can Ali show that the earrings are the same size and shape? So what this is getting into, if you want to show that they're the same size, the same shape, you want to show that they're congruent. And in this lesson, we have 2 properties that show that they're congruent: side angle side and side. We haven't looked at side yet, so I'm assuming it's going to be side angle side. Well, if you think about this, this is a rectangular piece of metal. Like I said, opposite sides are congruent. So the left and the right are the same length, the top and the bottom are the same length, and then all 4 angles are 90 degrees. So knowing that, here's that piece of metal. It looks like they already cut it down the diagonal, so it produced these 2 triangles. keep that idea of side angle side in mind. If we have two sides, any of the three, any two sides, and as long as the angle that joins those two sides is the same, we can say that those two pieces are the same. So again, we know that opposite sides in a rectangle are congruent, so that's why they're both 2 tick marks. We know that, again, opposite sides of a rectangle are congruent, so the top and the bottom are the same length. And then the angle that joins those two sides, that's also 90 degrees, because that's just the property of a rectangle. All 4 sides are 90 degrees, all 4 angles. So now that I know that the left side and the bottom are joined by a 90-degree angle. I know that the top and the right are joined by a 90-degree angle. So because of that, I know that I have side, angle, side, side, angle, side. And then that last caveat that I said about theorem 4.4 CPCTC, notice their statement down here. Once you've proved that these two triangles follow side, angle, side, you can say that the two triangles are congruent. And then that last statement, by corresponding parts of congruent triangles are congruent, all the corresponding sides and angles of the earrings are congruent. So the earrings are the same size and shape. So that's important. Again, we've got two triangles here. We showed that side angle side exists, right? And because of side angle side existing, we know that these two triangles are congruent. They're the same thing. So what you can say at the very end is, by CPCTC, all 3 angles and all 3 sides of each of these triangles are congruent. Theorem 4.45, side, side, side. So now they're getting into that second property that shows that triangles are congruent. Here's the definition. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the two triangles are congruent. So in this definition, you could see right here, these 2 triangles, ABC, DEF, that I've got AB is the same length as DE. They're both 1 tick mark. That indicates that they're the same length. BC is the same length as EF. Again, they both have 2 tick marks, so that indicates that the same length. And that AC is the same length as DE. I'm sorry, not DE. AC is the same length as DF. They're both 3 tick marks. So because of that, because each of these 3 sides corresponds to each of these 3 sides, I can say that those 2 triangles are congruent because of side, side, side. Like always, I'm skipping example 3. This is just a proof showing that side, side, side works. But again, we skipped proofs back when we introduced it a few lessons ago. We're skipping proofs from here on out. So if you want to kind of challenge yourself a little bit, go ahead and kind of walk yourself through this. Like I've said in the past, if you want to look at this proof with me, I'm happy to walk you through it and just kind of show you what this is talking about, but it's not necessary for this lesson. Example 4, determine congruent triangles. So I'm assuming they're going to throw in both side, side, side and side angle side. If you look at this first set right here, which of the following pairs are congruent by side angle side or side, side, side? If you look at all 3 of these sides compared to all 3 of these sides, this triangle has 1, 2, and 3 tick marks. This triangle has 1, 2, and 3 tick marks. So what I could do is say that these 2 triangles are congruent by side, side, side. These 2 triangles right here, it looks like they have a tick mark there, a tick mark there, 2 tick marks on that side, 2 tick marks on that side. And then that angle that joins those 2 sides is congruent to that angle that joins those 2 sides. So I could say that those 2 triangles are congruent by side, angle, side. Just remember, the 2 sides, it doesn't matter which 2 sides you're choosing, but the angle has to join those 2 sides. In this case, this is an example of almost, you might think, side, angle, side, but notice that the angle is not joining the 2 sides. Look at this triangle here. The side is this top side. This side is this left side. So if I wanted to use side, angle, side, my angle would have to join those 2 sides right there. It would have to join these 2. This angle is not joining those two sides. It's not like a, you know, it's not connecting those two sides. Same thing over here. It's not connecting those two sides. So I can't determine if those two triangles are congruent. They may be, but based off the information they're giving me, I can't use either side angle side or side side side. Over here though, this is very similar to the one up above it. Take a look. I've got one tick mark on the long side, two tick marks on that side, and then the angle that joins those two sides is included. Same thing with this triangle, one tick marks on the long side, two tick marks on the shorter side, and the angle that joins those two sides is included. So it's got side angle side. So those two triangles are congruent by side angle side. What additional information is needed to show that ABC is congruent to DEF by side angle side, and then also by side side side? So what else do I have to add? What other information do I need to show that these two triangles are congruent? Well, if I wanted to use side angle side, I would have to use BA is congruent to ED, right? That's what they're saying with that one tick mark. Those are the same. They're saying that angle A is congruent to angle D, which is good. But then the other piece of information I need is that AC is congruent to DF. Okay, that would show side, angle, and then that other side that connects those two, right? So I would need, in order to show that side angle side existed here, I would need to see that AC was congruent to DF. And then by side, 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 I would need two sides, right? The only side they're giving me is that AB is congruent to DE. I would also need to show that AC is congruent to DF. I would also need to show that BC is congruent to EF for side, side, side. All right, then at the top of page 171, we've got our concept summary. This is just summarizing side angle side and side side side. Don't forget that idea with CPCTC, corresponding parts of congruent triangles are congruent. That's just a statement that says once I've proven side angle side or side side side, once I've proven that and shown that the two triangles are congruent, you use CPCTC to show that every single angle and every single side must be congruent to each other. So now we're on page 172. We're going to take a look at the practice problems 17 through 22. So the first one, 17, prove that ACE is an isosceles triangle. And you can also go back and review examples 1 and 2 to prove that. So prove that ACE is an isosceles triangle, ACE. So that's basically this triangle right here in the middle. How we're going to do this is we're going to show that ABC, the triangle on the left, is congruent to CDE, the triangle on the right. Once we show that those two triangles are congruent, we know that CPCTC is in effect. So we know that the two sides of ACE, these two sides that go straight up towards point C, they must be congruent. They must be equal to each other. Okay. So we need either side, side, side or side angle side. It doesn't matter which one. In this case, they're not giving you side, side, side. Look at ABC. They're giving you AB is the same length as BC, but they don't give you that AC is any particular length. So we don't know what the length is for AC there. So I don't think side, side, side is going to work, but I think side angle side will. Take a look. AB and BC, that's given, right? They're actually the same length. They don't have to be, but they are. And then that included angle, angle B, the part that joins those two sides, we have all that information. So if you look over here at triangle CDE, same thing. CD and DE, we've got that those two sides are the same length, right? Looks like AB maps to DE and BC maps to CD. And then also that joining, that angle that joins CD and DE, angle D, is included as well. So I think we have side, angle, side, side, angle, side. So we know that these two triangles, triangle ABC and triangle CDE, are congruent, which means not only are they congruent, they're the same size. It means that all angles, all sides of ABC are congruent to all sides and all angles of CDE. So what that's emphasizing is that this side right here, that bottom part of that triangle, side AC, that's saying that that's the same exact length as that bottom part of that triangle, side CE. Now that I know that, look at that middle triangle. It looks like this angle here is the same as this angle here. So as long as this side, side AC, is the same length as side CE, that's the properties of an isosceles triangle. The two base angles are the same, and then those two side lengths are the same. So that's how you do it, using side, angle, side. What's the measure of angle? That's how you read that, the measure of angle RTS. So RTS, they're looking for this angle right here. Justify your answer. So I'm assuming what they want us to do is show that these two triangles are congruent, and then we can identify that angle, this angle T. It looks like this is angle D, right? Looks like angle D is the measurement, D degrees. It looks like angle R is the measurement, D degrees. So those two must be the same, all right? And I'm assuming they're going side, angle, side. So look at the sides that join that angle. It looks like side DF is the same length because of the one tick mark as side RT. Again, that has one tick mark. So that shows that those two sides are the same length. And then that side DE has two tick marks and side RS has two tick marks. So those two sides must be the same length. So it's looking to me like this is using side, angle, side. There's my first side. There's my angle, angle D. And then the second side. Same thing here. My first side, angle D, and my second side. So I know by side, angle, side that these two triangles are congruent. Once I know that, I know CPCTC is in effect. So not only are these two triangles congruent, I know that this side ST is congruent to this side EF. I know that this angle, angle T, is congruent to an angle over here. Angle S is congruent to an angle over here. We can prove all that information, or we have proven all that information. So let's kind of see, let's see what's happening here. We want to show angle, the measure of angle RTS. So RTS. So they're looking for this angle right there, angle T. So we need to see which angle it maps with over here. Let's take a look. It looks like RS is going to be this side up here. RT is going to be this side down here. So I think what I'm going to have to do is take this triangle and reflect it and rotate it. So I'm going to have to take this triangle, flip it over. Once I do that, once I take that triangle and flip it over, I'll spin it around, I'll rotate it, and it'll be right on top of this triangle over here. So reflect this triangle, flip it over, and then spin it around, and it'll be the same orientation as over here. Once I do that, angle T, once I flip this over and spin it, it's going to lay right on top of angle E. So what is the measure of angle RTS? The measure of angle RTS is going to be E degrees. Again, thinking about this, right, trying to picture this in your head is difficult. If you had a couple of these printed out on paper, or you had some like pieces of plastic, it'd be a lot easier to flip them over, spin them around and see that. But just kind of think about that for a second. Take that triangle, flip it over, just reflect it, and then spin it around, and it'll be the same orientation as over here. Number 19, what additional information is needed to show that PQR is congruent to STU by side, side, side? Okay. Looks like RQ is 8, and possibly UT might be 8. Again, if I take this triangle, it doesn't matter which one you take, and I flip it over, right? If I take UTS and I flip it, it's going to be the same orientation as RPQ. right? So take that second triangle, flip it upside down, and it'll be the same orientation as this right here. So what I'm assuming is that RQ is going to correspond with TU. So if this is 8, then what we'd have to know, the additional information, we'd have to know that TU is 8. It looks like they're telling us that PQ is 4. And again, that corresponding side right here, ST is also 4. So that's good to go. But then the other piece of information we're missing, they're saying that US is 6. We'd have to know that RP is also 6. So for number 19, we're missing 2 pieces of information. They're telling us that RQ is 8, but they're not telling us that TU is 8. We'd have to know that. And then the second piece of information, they're telling us that SU is 6, but they're not telling us that PR is 6. So we'd have to know that as well. Number 20, what additional information is needed to show that ABC is congruent to DEF? It's looking like they're giving us angle A is congruent to angle D. BC, that side length, is congruent to angle or to side EF because they both have 1 tick mark. Well, the only 2 properties we're seeing so far are side, 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 and side angle side. In this case, you can go both directions, but you need more information. So if you want to go side, 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 you'd have to know that AB, right, this side right there, AB is congruent to side DE, that those 2 sides are congruent, they're the same length. You'd also have to know that AC is congruent to side DF. So if you wanted to use side, 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 you'd have to have those 2 pieces of information. If you wanted to use side angle side, you'd still need 2 pieces of information. I mean, you could set it up a lot of different ways. If you want to use this angle, angle A and angle D, you'd have to know that AB is congruent to DE, and you'd have to know that AC is congruent to DF. So either way you go, it looks like you're missing a good amount of information with these. But just remember, if you want to use side, 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 you have to prove that all 3 sides correspond to another triangle that have the same 3 side lengths. Or if you want to use side angle side, you have to use a side, an included angle, and then the next side right after it. So 21 is RSV congruent to UTV? Explain. So RSV, so that's this left triangle right here. Is that congruent to UTV? Is that congruent to this other side right here? I think this is kind of going back. It's closely related to number 17. If you think back to number 17, they included an isosceles triangle. And that's what I think we have in the middle. So if you look here, that angle and that angle are congruent. And if you remember with isosceles triangles, if this exists, if you have 2 base angles that are congruent, well, then these 2 side lengths have to also be congruent. So SV has to be the same length as TV. That's a property of an isosceles triangle. If 2 of the base angles are congruent, then the 2 side lengths have to be congruent. Well, now that I know that this is an isosceles triangle here in the middle, and that these 2 side lengths are the same measure, you can see that these 2 triangles on the left and on the right have all 3 sides that are the same. Looks like RS is the same length as UT. Looks like RV is the same length as UV. And because this middle triangle is an isosceles triangle, that means that TV is the same length as SV. So because of side, 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 I've proven that RSV is congruent to UTV. And then the last one is PQR congruent to PSR. So PQR, PSR. So that's saying, is this top triangle congruent to this bottom triangle? And I would say yes, and here's the reason why. I would say because of side, angle, side, these 2 are congruent. Well, you might be thinking, where's my second side, right? If my first side is PQ, and then that angle is that part right there, then the other side that I need to show is PR, right? Same thing. If PQ is the same distance as PS, and this top left angle is the same distances or is the same measurement as this angle right here on the top left, well, because these two sides are the same, right? PR is PR. They're laying right on top of each other. These two triangles are butted up against each other. So the right side of this triangle right here is the same exact side as this kind of left side of this triangle here. Those two sides are the same exact, literally the same side. So because of side, angle, side, I know that these two triangles are congruent.